Swayam Prabha. Digital India. Educated India.
Namaskar. You have stepped into a course that is going to change the way that you look at data. Not just how you analyze it, but also how you communicate it. My name is Nivid Desai. I serve as the Program Executive at Writing Studio IIT Gandhinagar. Welcome to Writing for Data Science. This course is at the intersection of analysis and communication. As all of us know, data analysis is not just about coding and models. It is about solving real-world problems. And that is exactly why every single thought that goes into solving those problems needs to be communicated. And not just to one audience, across multiple stakeholders. That is where this course comes in. This course prepares you with the foundations of writing, especially curated for data science. We will discuss audience analysis, critical thinking, logical reasoning, as well as storytelling that is native to data science. So join me on a journey at the intersection of numbers and narratives. I'll see you in class. Namaste, hello and welcome to Writing for Data Science. My name is Nivid Desai and we are on a journey to explore the interesting intersections of numbers and narratives. In the last two lectures, we began a new module, Critical Thinking and Logical Reasoning. We spent the last two classes exploring each of these terms in its introductory respective sense. Now, we will spend the rest of few lectures in this module trying to go deeper into nuances and different sections of both critical thinking and logical reasoning. We also introduced ourselves with new vocabulary, new jargon that is native to critical thinking and logical reasoning. We revised the fact that we see writing as a process, not as a product, and that is why we are learning this module. If you remember, in the last class, I introduced two distinct structures to you, two distinct patterns in which people usually reason when they think about a logical conclusion. That's right, we introduced two new terms, inductive reasoning and deductive reasoning. I told you that we will spend some more time diving deep into both of these in detail. So, today is the day. We are going to explore inductive and deductive reasoning in their depth, trying to see what they mean, trying to see examples of what inductive thinking and deductive thinking may look like. But before we begin, I must justify to you why reasoning structures themselves matter in data science. Logical reasoning is not just about being correct. It is about being clear, coherent, and careful in how we move from data to insight. So, there may be one last answer that we arrive at, but the journey is more important than the destination in this case. Throughout the journey, we need to ensure that we are clear, coherent, and careful. This is why the two foundational types of reasoning are extremely important in guiding us through the process of reasoning. The first is inductive reasoning, and the second is deductive reasoning. As we studied in the previous lecture, inductive reasoning moves from specific to general, while deductive reasoning moves from general to specific. Both play important roles in data analysis and writing, but they are not interchangeable. Knowing the difference helps you write stronger arguments, make better decisions, and communicate more responsibly. Before we move forward, here's a question I would like you to reflect on. Why might a good data scientist need both inductive and deductive reasoning in their toolkit? Mind you, we have already established that they are not interchangeable. However, both of them are important. What do you intuitively feel? We have studied the basics in our previous lecture. So try to arrive at a conclusion. Why would you think that a good analyst or a good scientist need both of these reasoning styles in their toolkit? I will come back to you with a primer on inductive reasoning very soon. Let's begin by exploring inductive reasoning in detail. What is inductive reasoning? Inductive reasoning means moving from specific observations to broader generalizations. It starts with the data and ends with a probable, not certain conclusion. This is the most important part of inductive reasoning, that the conclusion is probable. Because it is moving from specific to general, it can only be probable, not certain. It is how we find patterns, trends, or hypotheses in data. So it has its own position, it has its own purpose. However, we must be wary of its unreliability, of its generalized nature, and the way that it is only probable and not certain. Let me show you an example. For example, in user behavior, the observation can be something like this. 4 out of 5 users who completed onboarding stayed active for 30 plus days. The inductive conclusion in this case would be that completing the onboarding is likely linked to long-term engagement. Now, the conclusion is probable, but not guaranteed. It is a pattern. It is not proof. It will need further reasoning. It will need further checks and balances to ensure whether this conclusion actually stands true, whether data truly backs up this conclusion. So, that is the probable use of inductive reasoning within data science. To notice trends, to notice patterns, and to build a hypothesis that can further be tested by actual cold hard data. Here's another example. In data science, there is a model called A/B testing, where two variations of the same thing are tested for effectiveness. So, here's an observation made by A/B testing. A variant B increased click-through rate by 12% over variant A across 3 campaigns. Therefore, the inductive conclusion can be that variant B might be more effective overall. Again, focus on the language. It says might be. It is not making a tall claim. However, because of the recurring pattern, because of the recurring trend, it is a likely conclusion that we must observe further to test whether it is true or not. So, from a bird's eye point of view, from a pattern point of view, the inductive reasoning has given us an area to explore. And that is why it is important. That is the purpose that it serves. Here's an exercise for you before we move forward. You observe that 7 of the last 10 customers upgraded after a live demo. you have to write a cautious inductive conclusion based on this observation. Mind you, it has to be cautious. You have to be extremely careful not to arrive at a certain judgment, but to leave a probable connection, a probable conclusion that leaves more gates open for further inquiry. Now that you have practiced inductive reasoning for yourself, let us look at the strengths and weaknesses of inductive reasoning. Here are the strengths first. Inductive reasoning, as we discussed, it is great for generating hypotheses. It helps identify emerging trends, and it is useful in exploratory data analysis. However, we go forward trying to gauge new areas to explore, trying to gauge new trends to explore. That is where inductive reasoning is a valuable tool in our data analysis routine. However, all is not rosy and sunshine. In this case, there are also many weaknesses. One of the primary shortcomings of inductive reasoning is that it can lead to overgeneralization. You may be looking at something specific, but you may be applying that specific observation to the broader range of data available to you, and that can always create problems. Inductive reasoning also relies heavily on sample size and diversity, and it does not guarantee a conclusion that is true. It only guarantees a conclusion that is just likely. It may be true. It may be like this. However, it can never be certain. So let us reflect for a bit before we move forward. When have you seen someone make a bold general claim from a small set of examples? They may have observed it twice or thrice, but they may have made a bold general claim declaring that so and so conclusion necessarily stands as true universally. That is an example of faulty inductive reasoning. Think about this. I will get back to you with deductive reasoning deep dive. Now that we have explored inductive reasoning, let us move through deductive reasoning in the same rhythm and explore how it differs and what are its salient features. Deductive reasoning moves from general principles or rules to specific conclusions. If the starting statements or premise is true, then the conclusion must also be true. This is a rather regimented, rule-based version of thinking. Let's look at an example. So in rule-based thinking, the premise can be something like this. All users who unsubscribe stop receiving notifications. And now our premise comes in, which is a little more specific. User A has unsubscribed. Therefore, what must be true? User A no longer receives notification. Because the first premise is true, therefore the conclusion must also be true. The first premise is general, the conclusion is particular, but it fulfills all the conditions that the first general premise has established. Therefore, it is a guaranteed conclusion. As long as the premise is true, the conclusion is also true. Let's look at another example. In analytics, this can also work out like you see on screen right now. All transactions above $5,000 must be flagged for review. And the more specific premise can be transaction number 6241 was $5,200. Therefore, the conclusion arises transaction number 6241 must be flagged for review. If you see, the first premise is a rule. The second premise is an incidence that falls within the rule. Therefore, the conclusion also is true because it follows the rule that we established in the first premise. I think that this rhythm is a little more structured as compared to inductive reasoning. While inductive reasoning moves from a specific to a broad, tall claim in generalization, this one first established a general principle. And from that, it tests every occurrence with that general principle and then compares whether that occurrence is true or not. Here's an exercise for you before we move forward. Write a short deductive argument. Start with a rule, then give one case, and then draw a conclusion. It doesn't necessarily have to be about a technical subject. You can also pick up something from your daily life. Just try to think in a deductive rhythm. Try to see if you can deduce something comfortably. I will get back to you with the strengths and weakness very soon. So here are the strengths and weaknesses of deductive reasoning. The strengths are that it is highly reliable if the premise is true. It ensures logical consistency. Because we have begun with a rule and then we have taken a case, the conclusion arrives naturally. There is a consistent logic throughout our entire argumentation. And it is ideal for technical documentation, model rules, and compliance. Because when you are dealing with something specific or something that is legally binding, you have to ensure that there's a consistent logic throughout the movement of truth in your argument. However, there are also obviously many weaknesses. The conclusions are only valid if the premises are accurate. So our first job is to come up with strong principles as general common premises. It also does not allow for any new discovery. It only follows logically. So you cannot take out an outlier example and then make a broad conclusion from it. Therefore, it only allows a certain kind of strictly regimented thinking, as opposed to inductive reasoning, where there is a lot more avenue, however uncertain, but there is a lot more avenue of exploration. So let's reflect for a bit before we move forward. Why might deductive reasoning be especially important in model validation report? You have developed a data science analysis model and you have to validate it for a stakeholder. Why would you use deductive reasoning and why would it be important? Think about it. Think of what deductive reasoning does. Think of what a model validation report does. Put two and two together, and I'm sure that some reasoning might emerge from it. I will see you again with the comparison between inductive and deductive reasoning very soon. We took a deep dive in the strengths and weaknesses and features of both inductive and deductive reasoning, but I have summarized all of this for you in a table that you see on the screen right now. I'm going to pause this table for a minute or so, make your notes, make your observations, and ensure that you remember this so that when we build further understanding, we have a foundational ground that we can come back to. And this table can serve as a ready reference whenever you need to brush up your knowledge about inductive and deductive reasoning. I will see you once again very soon. Let's look at inductive and deductive reasoning comparison with an example. This is an example of inductive reasoning. Most users who engage in week 1 become paying customers. Therefore, the inductive reasoning may be that week 1 engagement likely influences conversion. The deductive reasoning then arises that all paying customers must accept the terms. The deductive reasoning then comes into a specific premise. User X is a paying customer. Therefore, the conclusion arises that user X has accepted the terms. We have begun with a rule, then we have presented a case, and since the case matches the conditions of the rules, we have come up with a conclusion that matches the true premise. Like we have established in the very beginning, inductive and deductive reasoning are not interchangeable. However, a data scientist can benefit by learning to think in both these reasoning styles. Strong data science writing often blends inductive and deductive reasoning. You can use inductive reasoning to form hypotheses from patterns. You can use deductive reasoning to test those hypotheses or apply policies. So let's see this with a real-world example. The inductive reasoning may emerge with a specific observation. 80% of dropouts occurred after 3 days. So we arrive at our inductive conclusion that something about day 3 might be problematic. If you notice, this conclusion uses the word might. It is not sure. It is not certain. Therefore, we have to test this against present data and present principles. That is where deductive reasoning comes in. For another case, we can look at the deductive reasoning example. If users don't complete a tutorial, they can't unlock features. This is the rule. This is premise number 1. Then we arrive at the second premise, which is the case. User Y did not finish tutorial. Therefore, we arrive at the deductive conclusion that they did not access key features. Both of them have their own importance. Both of them have their own role. And a good data science communicator, in fact, utilizes both of them to make a strong, compelling argument. Before we move forward towards the conclusion of today's class, here's a little reflection for you. How does using both these reasoning types together make your writing and thinking stronger? Think about which reasoning style you use very frequently, and then try to accommodate the other style into your thinking pattern and see how will it make it stronger. How will this practice enrich the way that you approach problem solving? I will get back to you with the concluding remarks for today. In the end, once we have explored both inductive and deductive reasoning, we must establish a perspective. Writing is built on reasoning. Good data writing, like we discussed in the previous classes, it does not just report facts. It builds a reasoned path from those facts to conclusions, insights, and recommendations. So, whether you are proposing a change, defending a decision, or just communicating results, you will be more effective if you know when you are making inductive guesses and when you've applied deductive certainty. Again, both of them have their own importance, and you, my dear data science writer, need both of them in your arsenal to become a compelling data science communicator. So that was it from my side for today's lecture. We looked at inductive and deductive reasoning in depth. I hope that it was a fun ride, and I hope that the exercises particularly brought out a lot more applicability of both these reasoning structures. In the next class, we will start looking at the question that may have arisen in your head right now. These are the correct ways of doing things. How about when people make mistakes? And people do make mistakes, particularly in data science analysis. As we are all aware, this is a slippery slope. We can very easily make mistakes. So, in the next lecture, we will look at some common mistakes that exist in data science analysis, and we will also explore how to not make them and how to stay away from making those common pitfalls. Until then, stay curious, keep learning. I will see you in the next class. Thank you so much. Namaskar.